Okay, from rotation around the axis, day-night, we move to the revolution around the sun, the annual orbit of the Earth. And, quite familiar, as we go through the year, the weather changes. We have big effects from that as well. We're actually closest to the sun in now early January and farthest in July. That's enough to make it, on average around the globe, a few degrees warmer in December, January than June, July. But you've probably noticed around here, it's warmer in June and July than it is in December and January. So obviously we've got something else playing a bigger role than the distance from the sun due to the Earth's orbit. This illustrates that. In January, the distance from the sun is proportional to the top line versus the next line for July. Only 3%, 3.5% difference, not much there. The equator versus the pole, well, depending on what side is towards the sun, part of the equator is closer to the sun than the pole, but also the opposite side will be farther from the sun than the pole. But that difference is only 0.004% difference. That definitely is not enough to make any difference in how warm it feels due to the sun. 2 lines, well, it turns out actually PowerPoint won't draw lines that are different by only 0.00426. But you couldn't see if it did. So the distance to the sun is not our big factor in the Earth's temperature changes through the year. Yeah, if you go as far away as Mars, it's colder. If you get as close as Venus, it's warmer. But just the 3.5% difference of the Earth's orbit, not enough to be a big factor there. Instead, the big thing is combining going around the sun with the tilt of Earth's axis. Our tilt is very stable because of the gravitational interaction with the moon. Nice big moon helps keep the Earth's orbiting more stable. In contrast, say Mars has 2 tiny moons, just little asteroids that are orbiting it. They're not big enough to have any major gravitational effect on Mars. Mars has much bigger wobbles in its tilt. Seasons could get quite irregular long term on Mars. Not so nice for life. So, nice big moon helps Earth be more stable. But that combined with the tilt gives us significant seasons. Basically, the issue is, as the Earth is going around the sun, part of the time the north will be tilted towards the sun, part of the time the south will be tilted towards the sun. And so, more towards the sun, sun's coming in more straight overhead. All those factors we saw mean it's a lot warmer where it's getting the direct sunshine than when it's not. And so we can note different places where there's an important boundary of how it interacts with sunshine. We have the poles, north and south poles here. The circles, Arctic and Antarctic circles, at 66.5 degrees away from the equator. And the tropics, 23.5 degrees north or south from the equator. At the poles, say we start with the North Pole, up there with Santa. From the official start of spring for the northern hemisphere, the spring equinox, to the fall equinox for the north. During that time, the North Pole is tipped towards the sun, and so through that whole time, it's in the sunshine. You have a 6-month day for the North Pole. If the North Pole is towards the sun, South Pole's away. So while the North Pole gets its 6-month day, the South Pole gets a 6-month night. And then, of course, when we reach northern fall equinox, that's when the South Pole first gets sunshine and the North Pole gets in the dark. Now the South Pole gets its 6-month day and the North Pole its 6-month night. So North's spring is South's fall. South spring is North's fall. Which side's tilted towards the sun is the one that's getting more warmth, getting warmer. At the circle, that's the limit of where is getting midnight sun in the middle of its summer and a day with no sunrise, as in a 24-hour day with no sunrise, for its winter solstice. The rest of the year at the circle, they get at least a little sunshine, but it's always going to be relatively low angle. The sun's never going to be very high in the sky, so you're not getting a whole lot of warmth for those 3 reasons we looked at. If you're between the circle and the pole, you'll have multiple days of midnight sun around the summer solstice and multiple 24-hour periods of no sunrise, always in the dark around the winter solstice. The tropics, Tropic of Cancer is the northernmost, Tropic of Capricorn is the southernmost point where you get the sun straight overhead. And that will be on their summer solstice. But the rest of the year the sun gets pretty high in the sky at noon. So every day they're getting sunshine quite high in the sky, getting lots of warmth, again for those 3 different reasons that we looked at each day. Oh yeah, you know the tropics are warmer than the poles. This is why. Right at the equator, the sun will be overhead at noon on both equinoxes, the spring and fall, and the rest of the year gets close to overhead at noon. In fact, it may go past overhead during the day. Also, poles, we are having 6-month day and night. Circles, you had midnight sun, so still extreme variation through the year. Right at the equator, almost every day, you're going to have pretty close to 12 hours of sunshine and 12 hours of nighttime. So much more even day length near the equator, much different as you get to the poles. So this is what drives your seasons. Northern winter, that's when we're tilted away from the sun. Let's say the sun's over here. Then sunlight is coming in at a lower angle for us to the north of the equator. We're getting less energy from it. It's going to be cooler. If you're all the way up at the north, the Arctic Circle, you've got at least one day when the sun never makes it above the horizon. Meanwhile, the south is tilted more towards the sun. Sunlight's coming in more straight overhead, and it's getting warmer. If you're down to the Antarctic Circle, or even further south, then you're getting continual sunshine. Low angle, but long daylight period. Southern Hemisphere winter, now they're the ones tilted away, and the north is tilted towards. So here the north, their winter is our summer. Tilted more towards the sun, we're getting more energy out of that sunshine. And there's midnight sun from the Arctic Circle north, one day a year right at the circle more days as you get closer to the poles. Again, our summer will be their winter. But winter's a relative term. If you're near the equator, then year-round the sun gets quite high in the sky at the middle of the day. You're getting a lot of energy from it. And so it's basically summer all year. Now often there's, say, a wetter and a drier season, but you don't have nearly as much difference in the seasons as we see as we get further away from the equator. Okay, so here's an example. Looking at the tilt in this picture. Sun's this way. North, south here. North side's tilted towards the sun. That's going to be summer for us here in the northern hemisphere. Seasons. We're almost to the spring equinox, so soon it will be officially spring for the northern hemisphere. Equinox, equal night. So that refers to the fact that all around the globe on the equinox you'll have 12-hour sunshine and 12-hour night. There's a rumor that you can balance an egg on its end at the equinox because Earth is lined up with the sun. No. Earth and sun position are basically staying relative to each other all year. If you try hard enough, you can balance an egg on its end any day you have that much spare time on your hands. If you have a steady enough hand. It's not true that you can balance an egg better on the equinox, but it is the day of equal day and night length no matter where you are on the globe. So our equinoxes will be when the tilt of the Earth is sideways relative to the sun. So both poles and everywhere in between get an equal amount of sunshine. The solstice, those are the days when the sun reaches its maximum extent to the north or south. Summer or winter solstice, depending on which hemisphere you're in. So here, for us in the northern hemisphere, our spring begins around March 21st. Again, exactly how the calendar days line up with the position of Earth's orbit varies a little bit, but it's about March 21st, spring or vernal equinox. Our summer solstice then is somewhere around June 21st. And then our fall equinox is around September 22nd. Bilbo and Frodo's birthday, if that helps you. And then the winter solstice is somewhere around December 22nd. Again, that's northern hemisphere. Southern hemisphere, March would be the start of fall, June the start of winter, September the start of spring, and December the start of summer. Now again, this is the official calendar definition of what spring, summer, fall, and winter. Depending on where you are, it may feel cold or warm for different amounts of time. So here's the idea. As the Earth revolves around the sun, the revolution there, we go from north tilted toward the sun for our summer to being sideways to the sun for the start of fall, north tilted away for our winter, sideways again for our spring. Okay, but you may have noticed something. June 22nd or so is the starting day for our summer. That's the day when we have the most energy from sunshine. Why would that be the beginning of summer and not the middle of summer? Well, turns out that relates to why you have similar air conditioning in your car and your house. The air, ocean, land, takes a while to warm up, takes a while to cool off. So, yes, you're getting more sunshine, but you're coming off a winter. So it's still warming up. As we move on into July and August, here in the Northern Hemisphere, we are getting somewhat less energy from the sun, but we're still getting a lot, and we're already warmed up. So it stays relatively warm through then. Eventually, as we move to the equinox, we reach the point where it's more noticeably cooling down. As I mentioned, similarly, car and houses tend to have similar power of air conditioning. Your house is typically bigger than your car, but your house, weather's starting to get warm. Let's turn on the air conditioning and then let it do its thing. And you can basically just leave it going and have things at hopefully a nice temperature. Your car, on the other hand, you can't just have air conditioning running all the time. You've got it sitting parked, turned off, and so during that time, it can get pretty hot in there. Now, if you get in your car and turned on a low power air conditioner, and in about an hour, it's nice and comfortable in there, that's probably not what you want. Most folks want the car to get cool faster than that. And so in order to cool a smaller amount of air but cool it fast, the car has to have a more powerful air conditioner. And in fact, air conditioning is a big draw on your gas mileages. If you can deal with turning it off, you'll certainly save energy. Okay.